Morning, everybody. All right, this is 12.2, day 2. I'm trying a new format today. I hope you like it. I found this really great paper, and I hope it works out well. Okay, so the only rules we really need today are the facts. And here's all the rules. Remember all these different cool things we learned the other day. And the fact that all of these things are true, which is really, really great. I'm gonna get some more light over there. Okay. All these different things are true, which is awesome. But the cool thing is this one. Diameter perpendicular to chord cuts it in half and the arc, and the perpendicular bisector has the center. So there's all these different things. So if somebody says to you like, oh, look, here's a circle, and here's a radius, and oh, by the way, the radius is perpendicular to that chord, then what do you know? The chord gets split in half, and the arc gets split in half, and this radius is now the perpendicular bisector of that chord, which is pretty cool. So there's not really a whole lot that we need to figure out, but there's some really, really cool application problems with this. So I'm going to start with one like this. So let's say we've got this nice little partial radius right here, and all we know is something like, hey, what do you know? Now, the first thing we realize, since these two little segments are congruent, and because this is part of a radius, is that this is perpendicular. But then they're going to do something like this distance here. Let's make this kind of simple. This distance right here is 6 from here to here, and then they put something way over here like x, and then they say this segment right here is 4, and you're like, how in the world am I supposed to figure out what x is? So this is a really nice thing to realize, that if a radius portion is perpendicular to a chord that is perpendicular, and then you look at that and then you're like, oh, if it's perpendicular and it's a radius, that means this gets split in half, so both of these are 3, and then you're like, well, how do I find x? It's way the heck up there. Well, since this is a radius of a circle, you know that a radius can go anywhere. A radius can go anywhere. There's an infinite number of radii in every circle. Why not draw that radius instead to right there, and that would still be x. And what do you know? It's the good old 3, 4, 5. So x would be 5. So this is pretty cool, this idea of how do I actually take something and apply my knowledge to it. So let's say you've got something a little bit more interesting, not more interesting, just different. So you got this big old radius right here, and this radius is like 48, okay? And there's this other partial perpendicular to bloop bloop, and this guy is like 20, okay? This whole one is 20, this whole one is 48. So you're like, ooh, I got to put this together and try to figure out this distance right here. Now remember the other one where it goes, if two chords are the same distance from the center, they're congruent. So there'd be another one over here that had x, it'd also be 20. But let's do some splitting here real quick. So if that's 20 and that's perpendicular, that's 10 and that's 10. That's not really movable because that's just a chord. But if that's 48, that's 24, 24, then you think to yourself, maybe I could like create a little right triangle there. So if you put your 24 right there, and then you think to yourself, oh, x squared plus 10 squared equals 24 squared. So then you think to yourself, ooh, something 10, 24, that's something 5, 12. Oh, nuts, that didn't work, did it? I really wanted a 5, 12, 13, but it's not, and that's okay. I guess we're not going to use the 5, 12, 13 because that's the hypotenuse. Bummer. All right, that's not wrong. It's just not where we need to go with this one. So now I'm just going to go here and use my calculator and say, all right, let's go 24 squared. They always say nearest tenth. I always like nearest thousandth. You know that about me. 24 squared minus 10 squared is 476. The square root of that is 21 21.817. Okay, so something like that is kind of cool. So all these different little things with that. Now, there's a couple little nice applications with this as well that you will see, including I'm going to show you one problem that's on your homework sheet. It's this one. It's super cool. See how it goes. Sphere Z has a radius of 9, intersected by a plane that's 4 inches from the center. What is the radius of the cross section? Okay, let me talk about this for a minute. So I'm just going to start this problem that's on your sheet for you. So saying you got a big old sphere, and a sphere has a radius. There's an infinite number of radii in a sphere too, of course. But there's an infinite number of circles. Let me draw something over here for a second. If you have a circle or sphere, you got the great circle in the middle, which we call the equator if it was the Earth, but there's an infinite number of these like circular cross sections. See all these like beautiful little cross sections? And all of them, heck, there's even ones that go through here as well, right? All these cross sections. So what they're doing is they're taking a cross section that is kind of down here-ish, and they're saying, hey, you are 4 inches away. This radius is 9. And if you just think about it, like cute little right triangle as it is, to the nearest tenth, find the radius of the cross section. Well, here's the cross section. This little circle is the cross section right here. So if we're going to find the radius of the cross section, all we got to do is do Pythagorean theorem to find that, and we'll call that R. And you guys know the drill from here. Okay, so lots of good things going on, but really it's just right triangles inside of it. Hopefully all of these different rules and everything here still come into play and are pretty great, but not a whole lot of things going on new today. Just the idea that we can make right triangles and use those. So I hope you have a really, really great day. We got a little bit of a rainy day here today, but that's okay. And a great day to enjoy some math. Look for the quiz on Friday morning. Look for the answer keys tomorrow, and you guys can check those off. All right, thanks. See you later, guys. Bye-bye.